1.
All right, in this section here, our first section, we're going to be finding the derivative by the limit process. And of course, we're going to start with something easy, because this process can get pretty nasty. So let's say f of x is equal to, we'll just say 2x. All right, so that'll be our function. F of x is equal to 2x. Now what we'll need to do now is go ahead and write this formula that we're going to be using, and that is f prime of x, f prime of x is equal to the limit. And sometimes this is written differently. Sometimes there's an h here, but we're going to go ahead and use delta x. All right, we're going to go ahead and use delta x. Okay. I remember when I first learned it, they put an h there for whatever reason. So the limit as delta x approaches 0 over, so I'm going nice and slow here, so you should be able to write this stuff down as I'm writing this stuff out here. All right, and let me just copy and paste that. Okay, so is x plus your delta x minus f of x. Now you may think this looks complicated, but I promise it's not. All right, and this is all going to be over delta x. Okay, so this is going to be, this f prime of x is going to be your derivative. That's what we're going to be finding. All right, is equal to the limit. Now we must say as long as the limit exists. All right, as long as the limit exists, we'll be able to find f prime of x. All right, so by using this formula here, first thing I'm going to do is I'm going to go ahead and write this one here out, this f of x plus delta x, and we're going to do that one first. All right, let's go ahead and do that one first. And actually, what I want to do here is well, is it going to let me? I guess not. Okay, so we have f of x plus our delta x is equal to, now what we're going to do is we're going to take this x plus whatever's in parentheses right here, we're going to take this and plug it right in for this x right here. Okay, in other words, this x right here is going to get replaced by whatever's in parentheses right here. All right, so that means you're going to have 2 times, okay, x plus delta x. So whatever's in parentheses right here, whatever this is going to replace this x. All right. I know when I was first learning this stuff, man, that was hard to understand that, because I always got this x and this x mixed up. And these are two different things here. This is everything that's in parentheses goes in right here. All right. What we'll want to do here is go ahead and distribute that 2 all the way across if you want. All right, if you want. But I think we'll probably leave that off for right now. All right. So now I'm going to go ahead and rewrite this whole thing. And actually, instead of rewriting this whole thing, I think what I'm going to do here is see if I can't just copy paste that whole situation right down here. Okay, so you should be able to keep up with me here. All right, so that's going to get replaced with this 2, right, x plus that delta x. Okay, we're going to replace that. All right, you see that? So that got replaced. And then, of course, our f of x f of x is 2x. So you see that? That's all we got to do. Okay, that's all we got to do. Now what we'll want to do next is go ahead and simplify this. We're going to go ahead and simplify this thing down. And of course, I think what I'll do here is just, we'll just copy and paste it. All right. And up here in the numerator, I'm going to go ahead and distribute this 2 across, which means that'll be 2x. And then we'll put a 2 there. We're just distributing that 2 across. Okay. Now you see up here in the numerator, we have a negative 2x and a positive 2x. So 2x minus 2x is going to be 0. And so we're going to end up being left with, all right, so we're going to end up being left with just 2 delta x in the numerator. 2 delta x in the numerator. So let's go ahead and just copy and paste that. Alright, so hopefully you're able to keep up with what I'm doing here. So that's just going to disappear, and that's going to disappear there. Now you notice we have a delta x in the numerator and a delta x down here in the denominator. Well, those guys are just going to cancel out. Okay. Those will just cancel out, and we're going to just be left with, as you can see here, we're going to be left with the limit. So hopefully you know something about the limit. Hopefully. All right. Even though I'm not covering that, I'm covering that in the next section, or the next group of videos at some point in time. But I do have a website that has all that on there. All right, so the delta x over delta x cancels out, and what are we left with? We're just left with 2. That's it. We're just left with 2, and if I can write that in there, yeah. So the limit, so you should know that the limit of a constant is just the constant. So this whole thing is just equal to 2. I guess to use the same font, we need to probably get inside there. Okay. All right. So there's just a little bit of work to that, not much. So what did we figure out? We figured out all this right here is equal to 2. See that? This whole thing right here is equal to 2. Maybe we should just write that in up here so it doesn't look too confusing. Write it in is equal to 2. So what does this mean? This means that f prime of x, and I think what I'll do is I'll just go up here to the top. So we were trying to find f prime of x, right? That's what the goal was. F prime of x is equal to 2. All right, f prime of x is equal to 2. And of course, this is simple. This is just a linear function here, 2x. Oh boy, these things start getting difficult when this x becomes a square or even a cubed. Right, this starts becoming really nasty right here. All right, really nasty. Okay. So there we go. The goal was to find f prime of x, and we did, and f prime of x is equal to 2. All right. So we're going to work. About 4 more problems using this definition, the definition of the limit.